Very serious and interesting and important talks. This will be very much not important and just. So I don't remember when I first heard it, but I've heard the saying that everything is connected at some point in my life. And I don't want to debate whether or not everything is connected, but I have noticed that connections really can be found everywhere. Connections really are a part of us, of the world, from connections between people, between cultures, within language and nature itself. Some being literal connections, others connect us across time, and others only exist through the meaning we as humans give them. And in these days, when more data is being collected than we could ever hope to explore, the variety in connections being gathered is opening up the possibilities to visualize more of these often complex networks. So I've been doing data visualization and focused on it for a few years now, and I typically like to take on the bigger data sets, those that have a lot of diversity, so I can show context and other stories besides the main insight. And after I started freelancing, I noticed that a lot of my projects can really be seen as revealing connections. Some very obvious, some more subtle, some ending up as actual network visuals, while others need a different visual form to best display the insights. And during this talk, I'd like to take you through the design journey of several of my favorite connected projects, revealing the ugly truth that goes into creating these often big and complex and elaborate and interactive visuals and stories. And I want to start out with straightforward connections, literal lines that are being drawn, and only through those lines do the connections even exist. Constellations. So being officially an astronomer, I have a very big bias for anything space. I often get inspiration in terms of design from space. I mean, just look at the James Webb photo that was released today. It's gorgeous. And I also find myself creating a visualization about astronomy every once in a while. And so for my final project to a year-long collaboration that I did together with Shirley Wu called Data Sketches, I found myself turning back to astronomy yet again. So there were different projects, 12 of them, each of them had a different theme. And the final one had to be about myths and legends, which through a winding road of ideas eventually led me to the concept of myths in the night sky, because sure, I can pinpoint some of my favorite constellations, but those are all from Western culture. And I wondered, what if other cultures across space and time seen in the night sky? And are there certain shapes that almost every culture identifies with? So I drew this really tiny little sketch in my notebook, but in my mind, that sort of sky map would eventually be something that would definitely take inspiration from, the amazing historical sky maps and real life and whatnot. So really enthusiastic to get started. That was one big hurdle though, would there be diverse cultural constellation data available online? Seemed like a niche of a niche of a niche. But thankfully, I stumbled upon Stellarium pretty quickly, which is a free planetarium software, and even better, it's open source. And so after some digging around in their GitHub repo, I found that at that time they had constellation information available for 28 different cultures, from Western to Chinese to Korean to Hawaiian and even ancient Mayan and Egyptian. And after some data preparation, I was ready to make my visual, and I hate starting out with a blank page. So I generally try and look up some simple examples, and I used D3.js to program basically all of my visuals. And so I looked up some star maps from D3, and the code for this was actually pretty simple, not a whole lot of lines of code. It's all handled under the hood by the geo functions of D3. And so this was one of those rare cases where I thought I'd perfectly copy-pasted the code from the example into my file, plugged in my data, and everything would work on the first save and reload. But of course, real life happens, and all my stars appeared along the line. After looking a little bit deeper, I found my mistake, I thought, and then they appeared all over the page, but I wasn't really confident at that point anymore, so it could also be a random distribution of dots. So I just continued, we'll see once I figure out if this is wrong or not. I added a background grid, which seemed correctly, and then I thought, wait, I'll add those Western constellation lines because those I know. And then I immediately noticed Orion, which is my favorite constellation, Everyone has their favorite constellation, right? And this is, in essence, a sky map, but a very boring one, though. And so I spent hours trying to make it based more on reality by making it, having the stars have the proper color, making them glow, adding the Milky Way in the background, but also remembering what I liked from those historic sky maps, the embellishments of all of the degrees and the clipping it to a circle and the zodiac signs. And I'll spare you the details and just show you the final result, because it kind of comes down to setting up my grid area in terms of what I was really going for. Because this is sort of the base map that I ended with, but what would make my map most different from a typical star map would be the inclusion of several different constellations at once. So my approach was that I would take one star, and then I would visualize all of the constellations that used that one star. And so I started out by creating these little donut charts around all of the stars that were being used in all of those constellations together, to really show you some stars are being used more than others. And then I also wanted to draw these parallel lines between these stars, one for each of the constellations. And what I do typically when it comes down to these sort of geometry math things is that I draw out what I want in my little notebook and try and deconstruct it in terms of the math. And in this case, though, I wasn't really working. And then thankfully, though, I like geometry, but I really didn't like linear algebra during my astronomy years. But there are some useful things to linear algebra. I mean, there's actually a lot, but I remember the normal vector, which was just a very easy way to then have the formula for actually shifting these lines to the top and bottom. And so actually the parallel lines came about quite fast. And this is sort of the main visualization, and it shows you all of the constellations that use the star Betelgeuse. And when I first saw this, I thought it was so amazing to see that so many of these cultures are using the exact same sort of hourglass shape. But of course, each culture sees something different in them. From objects to mythical beings and persons, and even things that I don't even know what they should be, legends and myths. And of course, there are also those that kind of defy what everybody else has seen in them. I love this, I hope you can see it, it's a bit dark purple. This man that seems to be throwing a bow, boomerang, I'm still not sure. Or this one from the Egyptians that's much bigger even than Orion we're looking at this point. So that was pretty cool to see. I also looked at a lot of other stars. I looked at Sirius, for example, which is the brightest star in the night sky, but it doesn't have a lot of constellations. And that's, I think, because it doesn't have a lot of bright stars around it, so it doesn't have a killer shape. I also found this cute little deer shape in the southern hemisphere, which I hope to find when I go down there at some point, hopefully. And what seems to be the most common shape that these 28 cultures that I had on my data set identify with, is the one that we usually know as the Big Dipper. And I turned all of this into sort of an article that looks, like I said, like these stars and a lot of other stars, and looks at the data in different ways, also to kind of give a sense of how people saw connections in the night sky. And I generally work in the digital, and so I'm always really happy when I can take a little bit of my digital and turn it into the physical. And so I was really happy that there was some interest in this particular article, and that people thought, well, actually, I never knew about that. I never considered that. And then they actually wanted to have it into their home. So I was really happy to sort of create posters for the first time and then look into that. That was pretty cool. But I think when people think about connections, they probably think about family ties. How are you connected to your parents, your great-grandparents, and so on. And for another project in that Data Sketches collaboration, the topic was presidents and royalty. And I've always been intrigued by how intermarried the royal families really are. Are they cousins twice removed, or is it closer or farther than that? And I wasn't really looking for the last few generations of one royal house to create something more standard looking like this. No, I wanted as many connections as possible, crossing royal houses, going back as far as possible. And again, I was in luck. After some Googling, I found my way to this amazing looking website. Well, that's one of the things I definitely learned during Data Sketches. The quality of the designs is nothing about the quality of the data that it's sharing. But it had a gigantic family tree of 3,000 people connected to all European royal houses going back more than a millennia. It was from 1992, so I did have to spend an evening on Wikipedia adding 1 or 2 more generations in the main line of succession, looking up some other famous royals to get into the mood. But the problem that I typically have with these very interconnected networks is that it's very hard to draw anything less abstract than just a bunch of circles connected by a line. And that's because the best way to visualize a network is so inherent to the connections within the network. And so what I do instead is I plop all of the data on the screen as fast as I can with the network algorithm and then continue to go from there, see what I can find. I did that in this case as well, just plopped it on, let the network stuff do its thing, and then this happened. An explosion of points and lines moving out of my screen. So I thought, okay, I'll add a little bit of gravity to this giant cloud of points, but then there was this sort of tipping point, and I was left with a giant hairball. Not very useful, even if I colored it by year of birth. Thankfully, though, in the browser, you can play with the laws of gravity a little bit, and so I pulled it apart by year of birth, which was better, but it was still a rather uninsightful bundle. And at this time, I'd already spent several hours playing with the network settings, trying different kinds of connections, adjusting my data. And I was kind of ready to just give up and try a different angle, like how much are the royals spending these days? But it always makes you cry in a way. But I gave it one last shot. And that's when I decided to focus on the current royal leaders. So I placed these in a line as big circles. And then I let the vertical gravity depend on which of these royal leaders you were most closely related to. And that's when I finally saw it, insights. For example, that the Queen of Denmark and the late Queen of England and the King of Norway are quite heavily interrelated, but the Prince of Monaco line separated from Europe over 200 years ago. And it was only after I found the story, the insight, that I really started caring about the visual design. And like I say, I often get inspiration from space, and networks remind me of constellations. So that was the main reason why I just turned it into a starry night. Doesn't really have to have a good reason sometimes. And this is the final project, turned 90 degrees to better fit a typical screen. And because I wanted people to understand the connections, how closely people were connected, I added 2 types of interactions. So you can hover over any person and see how far 6 degrees of separation reaches into this web, which for this lady, Pauline of Württemberg, she's connected to 6 current royal leaders in only 6 steps. I believe she's called like the grandmother of Europe. But we can also click on anybody. Like, for example, we have the late Queen Elizabeth and Sissi, and we can see the shortest path between them, which in this case, they're not necessarily very closely related, but Elizabeth and the King of Norway are actually family. Like, it's not that far back. Thankfully, though, the royal houses have realized about 100 years ago that inbreeding is not a good thing for health. And so you can see that the lines have started to really separate out in the last sort of 100 plus years. Good thing. So I was connected to the Guardian US by a mutual friend. And through the Gates Foundation, they have an entire section on their website that focuses on homelessness in America. And for one of their flagship pieces about how homeless people were being bussed around the country by given free single-way tickets, they were looking for outside help. They'd been gathering data from cities and shelters about the bus tickets for over a year, and they were looking for someone to bring those to life. And because I knew this piece was too big for me alone, I asked Shirley Wu from the Data Sketches collaboration to become my partner on this project. And with my data science background, I took the data cleaning and analysis part on me. And all of these cities and shelters and all the data that was collected, was all in different formats, PDFs, Excel files, different ways to name it. So that was already fun. But the real fun really came in the shape of typos and state errors. Because to properly know where a homeless person was moving to, I needed an existing city. And so comparing against a sort of official data set of US cities, I created a collection of fuzzy text matching techniques that would try and figure out the actual city in cases where an exact match wasn't found. I manually checked each of these automated corrections to see if I agreed, but I also spent several hours on Google trying to find the city in cases when even my fuzzy matching couldn't help me. And that's how I've actually come to learn that the US should never have created 4 states that start with the letters MI. That cost me 6 hours of my life. So after all of this data analysis resulting in 35,000 journeys, the analysis part began. So the prep was done, the analysis began. And so I kind of dissected this data in several different ways, looking for trends and patterns. You know, what about age versus gender? What about big versus small cities? What destination was most popular? And what if you tried to account for distance? And simply visualizing these 35,000 journeys, I knew would be an important part of the whole, but just plotting them as lines from start to finish, it didn't really speak to me. I mean, it was just a kind of a mess. So I knew that needed something else. Well, partly due to lucky timing, everybody involved in the story could be in the same room together for 2 days, during which we figured out the entire story that we wanted to tell, and where Shirley and I figured out kind of at what points we need a visual to help the conclusion of the story. And one of my main visuals would be that map of the US showing all of these journeys. And I drew sketches then where I thought, well, instead of showing all of these journeys at once, I want to show each one separately. Each one should move from a starting point to the end point. It should become an animation. And then over time, circles would still kind of grow behind these cities to show, you know, where all of the homeless people were moving to. So, and then back home, you start creating it, and of course you start very simple and it gets more complex, but you get some silly results in the meantime, like if everything starts and ends at the same time, you have these tiny US's growing into the big one. If you give everybody the same speed, it's like a shock wave across the US, also not a good metaphor. But once you keep refining it, at some point it does start to look at, you know, what you have in mind. But I was still interested in these arcs. Like if I do an animation, what if I used arcs for the animation? So I kind of went into a tangent, trying to get these arcs to work again. Again, that doesn't work, you know, the first time, but got there. However, it wasn't what I was looking for. It was still very busy in a way. It wasn't really giving me the sense of people moving around. Even if I made these tiny little arcs, it was kind of weird. It seemed like somebody was moving through Canada to get from A to B, which it just didn't make sense. And so I went back to my little Streamlets and I tried lots of different things to add more, like being able to follow a person for a little while. But eventually we decided that the core was enough. It was enough to simply show all of these people moving. And to show you the final result, let's see, I studied the keystroke for going to the next tab. Yes. They don't do iframing, so I always have to switch. So here's the full article, and here we have that map. And if you haven't heard of it, this technique is called scrolly telling, where you basically have the visual stay in place, and then the text scrolls over it, and then the visual updates based on where you are in the text. So we have the animation starting here, and the goal for this animation is really to show you that so many homeless people are being moved across the US, and that they're going to places all across the US. It's kind of to give you the sense of the numbers of these are real people. And there are many more visuals in this story, as well as videos and photos and interviews, to really try and find a good balance between these very personal stories, but also the insights that this very high-level data set was able to provide us. What was it again? Nope. How did I get it right before and not now? I'll do it this way. All right. Sorry about that. All right. So we can also look at culture if we talk about connections. So since 2003, UNESCO has been gathering and safeguarding an ever-growing list of intangible cultural heritage, which can be anything from practices, knowledge, and skills that people see as being part of their cultural heritage. And about 40 new elements get added to the list each year, and it's almost 700 by now, maybe crossed 700 by now. And you can browse the list in this not so very inviting table on the UNESCO website. If you click on something, you get more information, as well as videos and photos. But there's something else here as well on the lower left, which is probably too small to see, but it's called concepts. And you can see this as tags. So people, experts of these cultural elements, have extensively tagged each of them. And so if you look at these different cultural elements, they all have their own tags, and there's no surprise that some tags happen for more than one of them, like vocal music being a part of all of these except for one. And while one man within UNESCO had this vision where people would truly be able to see and interact with these connections between these cultural elements, to see that maybe some cultural elements from places across the world could be very similar based on all of the shared tags that they had. Well, he had convinced management to give him some funding, he hired someone for the back end, and he came to me for the visual side. And he was very honest in his first email about the scope of the network. So at that point in time, there were about 450 elements still, some countries and regions that had to be taken into account, World Heritage Sites, and 1,000 different concepts. And that together gave me about 2,000 nodes, which is more of the technical term for sort of these circles in a network. And between them, they shared a whopping 12,000 connections. And I have to be honest, I did not know that I would ever be able to untangle that. I mean, the royalty project only had 4,500 connections, and that already was such a pain to sort of tease out. But on the other hand, I was a freelancer. I did not want to say no to a client like UNESCO. So I kind of just crossed my fingers, hoping that future me would figure it out, and said, yes, of course, I'll do it. Well, like the royalty case, though, I completely skipped any sketching phase that I would normally do and just plopped all of the data on my screen. And also, as fully expected, I ended up with hairballs. Giant, infectious-looking disease things kept appearing on my screen no matter what I tried. But there was one aspect of the data that saved me. Not all of these connections were of equal importance. So if you go back to that table and we have the concepts, there are actually two types, well, three actually, but there are primary and secondary concepts. Like the tango, it has dance, instrumental, and vocal music as the primary concepts, but it has a lot more secondary ones like choreography and emotion. And although UNESCO did not want me to aggregate away any of the connections, they were okay with me just using the primary connections to place everything in the network in a way. So I temporarily filtered out anything that wasn't a primary connections to a cultural element. And then I redid the network, and I saw this, where the yellow ones are the cultural elements, and the concepts are all teeny tiny because I didn't want to care about overlap for now. But this was looking a lot more ordered. In fact, I felt that I was starting to see communities, which would be a great way to untangle this web one step further. So in network analysis, you talk about communities when you have groups of nodes that are more interconnected between themselves than they are to the rest of the group. And then smart people have written algorithms to find these communities, which I can then use to then, for example, color each of them differently. Which is what I did here as well, using just, basic rainbow scheme. But it was definitely seeing that there was something going on here with like this green over here, and then there's this sort of lilac over here and the orange. So this was looking well. And at that time I thought, well, by now it's also, let's look at these concepts, because I want to play with that as well. Let's give them a size that's based on how many connections they have, such as vocal music is used a lot, so that one becomes very big, and wood is not used that much, so it becomes very small. It also creates some visual diversity, like something that makes it more interesting for the eyes to see if there's like a little bit of a change in sizes. But I thought, typically a network algorithm places everything on the page randomly at the start, and then tries to sort of use the connections to figure out where to place it. But I thought, I kind of know what should belong together. I know what should be in one community. So I don't want them to start randomly, because sometimes it just kind of gets mixed up in a way. So I thought, well, I'll place them in a circle. Instead of randomly, I'll place everything in a circle, and then I will let the network algorithm do its thing. And I was really happy to see that in this case, most of these circles, they stay pretty close to that starting point. They really only move because I don't want any one of them to overlap, so I really forcefully push them out. And there's really only some of them that get drawn towards the middle because they have more ambiguous connections. And that's how it showed me that looking at this particular network from the angle of communities was really fitting with the connections in the network. Well, it was time to put everything back in that I'd filtered out before, placed initially kind of averaged on what was already there, and then ran a second network algorithm to have it move about based on everything, and there we have the base network. I did go to a different rainbow scheme, still rainbow because there were a lot of groups to work with, but I also used different shapes like hexagons, diamonds, filled circles, stroke circles, and I kind of liked how if you zoomed in, it reminded me a little bit of like a schematic look, of artistic look of outer space. And my client at UNESCO started calling this visualization the constellation, which of course, again, an astronomy theme, so I didn't object at all. But now, thankfully, the circles were figured out, and it was time to look at these lines. So how to handle 12,000 lines. Well, gray and straight is boring to me, so I made them curved and colored, but yeah, 12,000 lines of full opacity is not good. So again, I had to sort of think about how am I going to handle this. So not everything worked out, but eventually I came upon the idea that it seems so obvious afterwards, but if you hover over something, you see all of its connections, with the primary ones a little bit thicker than the secondary ones. And then if you don't hover anything, it really only shows you the primary connections. There are much fewer of those. But of course it didn't end there, because the client also wanted it that if you'd hover over a region, it showed all of the countries and then all of the cultural elements connected to that. You had to be able to send a query to the visual, which would then fix everything. If you clicked on a node and fixed it, you would still have to be able to hover over everything else and get information. If you zoomed in far enough, the photos had to be able to show off the cultural elements, and if you clicked on something, you'd still have to be able to click on something else, then see a modal pop up with more information in videos and photos. And that was just the tip of the iceberg. And I'm not trained to do interaction programming, so this is like a beast underneath in the code. But here's the actual visual. Let me kind of show you how it works and what the idea is. So let's say you start here, and let's kind of zoom in and just pick this one. I will not be able to pronounce this. So we'll have this cultural element. And if we click on it, we can see all of its connections. We can see that it's about democracy and percussion instruments, and we have art education. We can click on that line, and we're taken to the other side, and we can see this is also connected to some cultural elements, like graphic arts, the fine arts, I guess, so it's an in-between one, and this one is connected to Chinese calligraphy. That makes sense. And then we can see, it has to do with weddings and cultural elite and art. Aesthetic education, kind of like weddings, so I'll go there. And of course, there's quite a lot connected to weddings. And that's kind of how this visual tries to make it a little bit playful, to make you move across this map from different place to different place, and kind of show you that in the end, I mean, it takes much less than 6 steps to get from one cultural element to the next. And this is a really fun project in the end, because also, how open UNESCO was in letting me try things to tackle this network, because it didn't seem like we would ever be able to figure it out at the start. So now I want to look at connections within language, depending on how you look at sentences and similarities between sentences. So for the past few years now, Google News Lab has been asking data visualizers to create data-driven stories based on Google data. And I'd already made one about translations. As a non-native English speaker, I was always interested, like what single word is used, like translated most often in Google Translate. And I'm so happy that it is a word you can say at work. It's beautiful, actually, so that's nice. That was really helpful. But they came back to me to ask me to do another one, and this time I came up again with a set of ideas, but there was one that really stood out to both me and my contact at Google, and that was doing something about pets. So having these cute little fluff balls in my house, I mean, they're like 4 times bigger by now, but I found myself on Google quite often recently, just trying to figure out some certain behavior, or why this, why the boxes, why, And I was kind of curious, why, what do people search for on Google to better understand their pets? And the approach was like this. I would get the most popular questions that people ask about cats and dogs. So, why does a cat? Why do cats? Why does my cat? And then the same for dogs, and look at, similarities and differences and trends and patterns and make that into a story. And I drew this sketch for them, like what visualization I wanted to create. And my main visual was this thing in the top left, which I call kind of like a word tree, a sentence tree, where I would break apart all of these sentences and rebuild it in this kind of tree-like structure. Let me try and explain that a little bit better though. So in the end, I got 2,000 of the most popular questions that people ask about cats, like why. And from that I can say, well, give me all of the things that have the word like as the first word, why do cats like? Which gives me a smaller set. But from that set, there are actually 3 that have the word boxes as the second word, so I can combine that one step further. And if I keep continuing to do that, I will eventually create this sort of tree-like structure where I can build up a sentence again by following the lines from left to right. So why do cats like to go in the bathroom with you? Which is a thing, yes. Or outside, to go outside. But this is taking up a lot of space. So I thought instead, I want it to be around this sort of central like circle, but I also want the circles to be scaled based on popularity. So why do cats like boxes is much more popular than why do cats like feet. And my cats don't like feet, I don't think so. But this is only one small part of the data, and I actually wanted to create this kind of tree for all 2,000 questions at once. And so my quest began, where I started out with this very simple network and then trying to make these connections visible. But I also had to really increase the size of these circles because I wanted as many of the words that the circles represented to be inside of the circles. That would just make it easier for people to understand, to relate with this visual. However, that made the circle so big that these connections between them just became these sort of gray blurs going outward. You couldn't see who was the parent circle and who was the child circle. And so I had to try all kinds of things to make that clear. Like I tried to group all of the sort of the children of the same parent, but then it was still unclear who the parent was. And then I would get the strangest things at times where here I still do not know why they start rotating. I would just have to undo in my code and until a point it stopped doing it. Maybe some random stuff, I don't know. And when I had some bigger ideas, I would draw them out in my notebook to see if they made sense. I'd spend hours actually coding it and then actually seeing that no, it doesn't actually work when you apply it to all of this data. I would get chaos from time to time. I kind of like this one though. And I don't know how many things I tried. And in the end, I even made everything draggable. I thought, if I can program it, I'll just do it manually. And it took me about 2 hours to kind of manually drag this right-hand side. I took a step back. I was like, it's just still not working for me. It's not getting me to the point where I think this will make people want to look into it. So, and at this point, this was 40 hours after that initial network thingy. And that's when I finally decided to give up. But it was a client assignment, so I need to deliver something. And what I typically try and do, and you'll see that later, is that I look back on everything I've done, because sometimes I can have these blindfolds on, like that is my goal, and if it's not exactly that goal, I'll just ignore it. But now that I'd sort of given up on that particular goal, I look back and see, is there anything interesting that I did that I could maybe work with? And that's when I remembered the mini trees. Like at some point I tried cutting the connection to the main central cat circle so that each branch would become its own mini tree. We'd already seen like before, but there's also lick and need and meow. And again, of course, this didn't go right the first time. But it did, when I remembered thinking that these mini trees were actually a lot more easy to understand and to look at and more fun in a way. And so I thought, how can I use these mini trees? So I'll try and put each mini tree in a circle, and I'll let these circles sort of group together. So what happens now is that I have a bunch of circles, I just randomly place it, then I have an algorithm that pushes everything aside so it all fits,